Hello everyone, my name is Rodison Ostabalahon, the leader of Group 1's ICT Greenhouse Performance Task, and these are my members, Zian, Antonio, Dwayne, and Andrea Jacob. Now throughout this quarter, we have made multiple Tinkercad projects that is essential for greenhouses, such as soil sensor and water sensor. Two different projects that is beneficial to help greenhouses produce. But what if we were to make a circuit with those two components together? Which is exactly why me and my group work together to combine the two components into one working greenhouse circuit. I present to you our ultimate project, where both soil sensor and water sensor are combined into one functional circuit. And before we get straight to showcasing this, let's go through the components or parts one by one, where my good members Zian Harold Badayos will be illustrating.
Hello everyone, my name is Ian and I'm one of the circuit builders. And right now, I'll be guiding you through our project. Let's go through the components one by one. For the basics, we have the Arduino Uno, resistor, and the breadboard, which is always going to be needed for every project. The LED RGB that lights up when the water sensor is either low or high. We have the piezo, which is by far the loudest of them all. It creates an irritating alarm if the water is too low. The ultrasonic distance sensor and the LCD I2C. Finally, for the important parts, we have the micro servo, aka the water sensor, which detects and measures the water. The soil moisture sensor that's responsible to measure the moisture of the plant soil. And finally, our additional part, the temperature sensor. That, of course, detects the temperature inside the greenhouse, making sure that the air is normal and safe, enough that it won't damage the plant.
Thank you, Zian, for that wonderful information of our components. Moving on to our showcasing, where my good friend Antonio will be helping me. Now, if I press the start simulation, as you can see the micro servo rotates, which means it's doing its job. As the LED lights up blue, then that means the water is normal. Watch as I move the ultrasonic all the way to the bottom. The piezo reacts, causing an irritating noise, which is the alarm, and is signaling that the water is too low. Now, moving on to the soil moisture sensor. You know what? I'll let Antonio explain this one. Antonio?
So, for the soil moisture sensor, its main job and purpose is to measure the amount of water in the soil, which is essential for greenhouses and agriculture since it helps us know if the soil in your plants are standing on either dry, moist, or wet soil. So who knows, your soil might be harmful for your plants.
Thank you, Antonio. Now we've showcased the two important parts of this project. Let's move on to our additional, which is the temperature sensor. It may sound optional, but trust me, this component is actually very useful during the heavy weathers. Sometimes the air can be too hot, or sometimes too cold, and even worse, way too humid. It can detect if the temperature is still valid for our crops, a way to keep them safe because at the end of the day, you might never know how bad or good the temperature can be. Examples like humidity. High humidity can lead to a lot of problems, including diseases that could mold and rot your plants, which is why we added the temperature sensor to always stay on the good side when keeping our plants safe. Oh, and one more thing, let's not forget about our LCD I2C. This shows the result of all three components one by one: the water's level, the soil's moisture, and the temperature. And one more thing I would like to showcase, the codings. As you can see, our codings over here that took us a couple of meetings to complete, with me and Antonio working together as DE coder. Well, actually, Antonio did most of the work, and I credit him for that. These codings hold the function of all three components, and throughout this project we did stumble into multiple errors when working on these. But that isn't a problem, because at the end of the day, we fixed it and finished it. Now, that would be all for this project. Throughout this showcase, we reflected on how useful these circuits could be. After all, electronics are a way to help and protect crops and greenhouses. And I couldn't have done this without my group members, of course. Credits to everyone, for the circuit builders, Credits to Andrea Jacob Ambrosio, Dwayne Denver Yao, and Z and Harold Badayos. For the encoders, credits to Antonio Javino Montibon. For the video presentation, credits to Z and Harold Badayos and Antonio Javino Montibon for joining me. And that will be all for this video. Thank you so much for watching, and until the next ICT project.